Hello, mathematics. It's me, Sir Andy. Welcome to my channel. For today's video, I'll be sharing to you one of the topics about geometric sequence. But of course, before anything else, please don't forget to like and share my videos. And if you're new to my channel, please don't forget to subscribe. I will try my best to discuss the geometric sequence, specifically sum to infinity. So, just relax and enjoy watching my video. I have a question. Is it possible to get the sum of an infinite number of terms in a geometric sequence? You will say maybe, or some may say yes. Let's see. Let's consider this infinite geometric sequence 1 half, 1 fourth, 1 eighth, 1 over 16, and so on. So as you can see from our sequence, 1 half is its common ratio. So I have here a table showing the first 5 values of S sub n. So when n is equal to 1, the S sub n is equal to 1 half, since it is the sum of the first term only. And when n is equal to 2, the S sub n is equal to 3/4. And since it is the sum of the first term, which is 1 half, and the second term, which is 1/4. So that's why it became 3/4. So as to the next values of n, if n is equal to 3, you need to add the first 3 terms, which are 1 half, 1/4, and 1/8, which is equal to 7 over 8. Therefore, S sub n is equal to 7 over 8. So the same process also will be applied to n is equal to 4 and n is equal to 5 to get their corresponding values of S sub n, which are 15 over 16 and 31 over 32 respectively from our table. So all of these values in the table are solved through the use of the formula S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. Remember that formula? I hope so. Now, what happens to the value of S sub n as n gets larger and larger? So, as you observe from the table, as S sub n approaches 1, as n increases, we can say that S is equal to 1. To illustrate further that the sum of the given geometric sequence is 1, let us show the sum of the sequence on the number line, adding one term at a time. So I have here a number line from 0 to 1. From the given sequence, the first term is 1 half, and it is represented from 0 to half of the number line, followed by 1/4, as shown in the number line, so as to 1/8 and 1 over 16. So there you have it, the terms shown in the number line, from 1 half up to 1 over 16. So as you can see from the number line, what does it tell us? So clearly, 1 half plus 1/4 plus 1/8 plus 1 over 16 plus and so on equals 1. So the sum that we got from the illustration refer to us as the sum to infinity. Take note, the common ratio in the sequence is 1 half, which is between -1 and 1. So let us recall that S sub n is equal to a sub 1 times 1 minus r raised to n over 1 minus r, which is also equal to a sub 1 all over 1 minus r minus a sub 1 r raised to n all over 1 minus r. Suppose that negative 1 less than r less than 1, as you can see from our common ratio, which is 1/2, as the number of terms becomes larger, that is, n approaches infinity, then r raised to n approaches 0. And a sub 1 r raised to n divided by 1 minus r from our equation approaches 0. So, the sum of the terms of an infinite geometric sequence, a sub 1 as our first term, a sub 1 times r as our second term, and a sub 1 r raised to 2 or r squared as our third term, and so on, where negative 1 is less than r less than 1, the formula will be sum to infinity equals a sub 1 over 1 minus r. So that will be our formula now in finding the sum to infinity from our derivation. So let us try the first example. So in our first example, what is the sum to infinity of 1/2, 1/4, 1/8, and 1 over 16, and so on? So let us solve. For our solution, since a sub 1 is equal to 1/2 from our problem, and r is equal to 1/2, so r is solved from a sub 2 divided by a sub 1. So we have 1/4 divided by 1/2 is equal to 1/2. Then, sum to infinity is equal to, using the formula, a sub 1 all over 1 minus r. So simply substitute the values. We have now the value of a sub 1 is 1/2 divided by 1 minus the value of r, which is also equal to 1/2. Simplify further. We have 1/2 divided by 1 minus 1/2 is equal to 1/2 also. And then 1/2 divided by 1/2 is equal to 1. So that is our sum to infinity given the sequence 1/2, 1/4, 1/8, and 1 over 16. So, what have you noticed from the first example? We got the same answer as what we have seen from the number line. So, let's take the next example. So, the problem states that what is the sum to infinity of 3, negative 1, 1/3, and negative 9 over 4, and so on. So, let us solve again. So, for our solution, since a sub 1 from our given is 3, and the value of r is equal to negative 1/3. Since our a sub 2 is negative 1 divided by a sub 1, which is 3, so our common ratio equals negative 1/3. Then, let's use the formula. So we have the sum to infinity is equal to a sub 1 over 1 minus r. Simply substitute the values that we have from the given. A sub 1 is replaced by 3, and 1 minus r replaced by negative 1/3. So we have now the equation 3 over 4/3. And 4/3 came from 1 minus negative 1/3. So negative times negative 1/3 is positive 1/3. So that's why we have 1 plus 1/3 if we are going to solve for the denominator. And it is equal to 4/3. So simplify further. 3 divided by 4/3 is equal to 9/4. So that is the sum to infinity of our example number 2. So that's it, mathematics. Another topic for you to explore more and learn deeply. God bless everyone. Thank you for watching. And again, don't forget to like and share this video. And for the newbies to my channel, please subscribe. Bye.